is 4. For example, if you had 4 apples to be divided between 17 people and the apples could not be sliced up, then no one would get any apples, and the remainder would be 4 apples. So notice that all the sequences start with 0, 1, 4 for this reason, because the remainders are the actual squared number because they can't be divided. Once you reach a number that can be divided by the prime number, in the prime number, in prime 17 sequence, this would be 5 squared. You can use this calculation to work out the remainder. 5 squared equals 25. So 25 divided by 17 equals 1.4705888235. And you need to put in all of the decimal places or the number will be slightly different. So 25 divided by 17 equals 1.4705888235. Then you minus the whole number, so minus 1, and you're left with the fraction. You then times the fraction by 17, which equals 8 in this case. This could also be worked out without a calculator by thinking of the apple example again. So 25 apples divided by between 17 people would leave you with 8 apples. But when the number gets really big, it is necessary to use the method above to make things a lot easier. For example, 15 squared equals 225. 225 divided by 17 equals 13.23529,412. So minus the whole number, which is 13, you're left with the fraction. You times the fraction by 17, and this equals 4. This relates to the sequence here. You can see that the 15 squared modulo 17 does equal 4. Once you get to 17 squared modulo 17, the remainder will be 0, and the sequence will just repeat from then on. Notice that the prime 17 sequence has 17 numbers, the prime 23 sequence has 23 numbers, and etc. See, so, and the prime sequence 5 has 5 numbers, and so on. Applying the number sequence. When a sound wave hits a diffuser and is reflected, the magnitude stays the same, but the phase is different because of the time it takes for the sound to travel down the wells and back up again. Hence, the sound is scattered. To figure out how to design your diffuser, you need to know which number sequence to use in order to calculate how deep each well will be. The depth of each well will be more than or equal to 1/4 of the wavelength of the frequency to be diffused. So the lower the frequency, the deeper the well needs to be. So for this reason, we need to take the lowest frequency we wish to diffuse, and the diffuser will diffuse everything above this frequency. Let's say we want to start diffusing, let's say we want it to start diffusing at 250 Hertz. You use this triangle equation to work it out, with V being the speed of sound, which is 344 meters per second, F being the frequency, which in this case is 250 Hertz, and that sound equals the wavelength, and that's what we want to find out. So 344 divided by 250. 344 divided by 250 is 1.376. But this number's in meters, and we need it to be in inches for it to relate to the number sequence, which is in inches. You just need to look this up on the internet, which I've already done. So 1.376 meters is 54.17 inches. So now that we have our wavelength, we divide it by 4, because the well depth is 1/4 of the wavelength to be diffused. 54.17 divided by 4 is 13.54 inches. So if you look at the number sequence, we need a sequence that goes up to 14 at least, because we need it to diffuse the 250 hertz. So we need to make sure the well depth is big enough. Prime number sequence 13 only goes up to 12, so we can't use that one. So the next one that you can use is prime 17, which goes up to 16. So that's the sequence you need to use, basically, so that it will diffuse sound waves from 250 and upwards. Also, now you have your measurements, you can make a quadratic residue diffuser. I've also got a video showing, where is it? There. Just showing a sound wave being diffused, basically, or not, really a simulation. Is it not? Oh no. Should have loaded it before. Oh, that's the wrong one. That's one of my references, that's not the video. Here we go. So this is a simulation of a sound wave being diffused.